Okay, hi and welcome to Video Notes 10.7, Solve by Factoring. Now, since we're already experts at factoring, we'll be able to kind of go through that and you'll feel really good about it. So really, there's only one new piece to what we're going to do today, which is, by short notation, ZPP or Zero Product Property, which really just means once you've factored a quadratic so that it's in factored form, and you'll see in our first examples, those are where we're going to start, factored form, which looks like this here, and looks like this here. So x plus 3 times the quantity of x plus 2, see that looks like it's factored, and it already is. So in that form, we apply the zero product property, or the ZPP, which says that you can take either of these linear binomials, since they're set equal to 0, because that's what it means to solve, right? And you can set them both to 0. And in doing that, look at what you got. You've got one linear factor and a number, because that's what they should come out when you factor it, right? You should get a linear binomial, which is a linear factor and a number, and you should be able to solve that really easily, usually. And so what you'll do is you'll solve two of them if you have to, and then that will be your intercepts, wherever that function happens to cross, or that quadratic happens to cross the x-axis, because remember, that's what these are. We're finding x-intercepts. Okay, so let's jump into some that have that's already in factored form, meaning it's been factored for us. So here's some examples you can look at, but let's do number 2 real quick. Again, there's nothing to do to get to this one because it's already factored. So we're going to just quite literally, by the zero product property, take the first linear binomial, 3y minus 12, and set it equal to 0. Additionally, we're going to take the other linear binomial, y minus 2, and set it equal to 0. We're going to solve both and find our y-intercept. So let's go ahead and do this. We're going to add 12 to both sides, so we're left with 3y equals positive 12, and then I'm going to divide by 3 on both sides, so y is equal to 4. Or, better yet, we're going to write these as points through this unit for 0. That's the x-intercept, right? All x-intercepts have 0 for a y-coordinate. This one's even easier to solve. Add 2 to the other side, and we find out that y is equal to 2, or the point 2, 0. Super simple. That's quite literally the only new piece of information that you have, which is the zero product property. The rest of it is skills you already possess. So let's take a look at a couple though. We're going to scroll down here. Let's take a look at solving ones that have an a value of 1, which means that it's already in quadratic form, not in factored form. So if you recall, even though that's an easy kind of one, we take a times c and we put b in the bottom, and we go ahead and say a times c, which is 1 times negative 20, or negative 20, has to add to the b value, which is 1. So what two values that multiply to negative 20 are going to add to 1? And of course, that's going to be 5 and negative 4. They're going to multiply to make a negative 20, and they're going to combine to make a positive 1. So since a is 1 right here, we don't have to go any farther and do any grouping. All we have to do is go right to our factors, which will be p plus 5, right, this factor, and then times the quantity of p minus 4, this factor, and set that equal to 0. Now we're in factored form just like the one above, so we're going to set them equal to 0 by the zero product property, both of them, of course. And we're going to go ahead and solve. So we find out that p is equal to negative 5 and p is equal to 4. Or, better yet, negative 5, 0 for the intercept, and 4, 0 for the intercept. So again, if we were graphing, we go over negative 5, there would be 1 point. And we'd go to 4, there would be another point, and the quadratic would go through them as x-intercepts. Awesome, right? No problems. We're even going to skip the other example over here. Well, you know what? We'll do one thing with this example. Notice that it's not in standard form. So don't get your cart in front of your horse. Make sure that you apply it to standard form first by, of course, adding x here and subtracting 40. So if we add x, we're going to get x squared plus 3x and then minus 40. Now we're set equal to 0. I'm not going to take that one any farther because those are pretty easy. And again, if you want to see some more, take a look there. All right, let's take a look at one more section then. Okay, so before we go to the next section to do the last set of problems, let's just review really quickly what it meant to solve by factoring if a value is not 1. Remember, your first choice should be to always look for a GCF to take it out. Then, of course, we're going to go ahead and do the x and make a list of factors like we've done before, if necessary, of course, based off of whatever a times c is to help us out with these two parts. Then we're going to turn that linear term, whatever the bx value is, we're going to split it up into those two factors that we found, right? And then we're going to have 4 terms, in which case we're going to do our grouping, and then we group again. You've seen that before. And then finally, we'll use the zero product property. All right, so let's take a look at one. So here's the first one we're going to look at. Notice again, right away, that your a value is not 1. So in that case, check to make sure it's in standard form. X squared, quadratic term, linear term, and then constant. Agreed. That looks like standard form. And set equals 0. Perfect. It's all set up. Now let's check to see if there's a GCF. Well, 3 is not divisible with 13 and is not divisible with 10. So at this place, we're not able to take a GCF, which is perfectly fine. So now we're going to start our x, and we're going to say a times c, which is 3 times negative 10, or negative 30, right? We're going to go ahead and see what two values, or what values of them that multiply to negative 30 are going to add to positive 13. So let's make ourselves a little list over here. So what values of negative 30, what multiples of negative 30 will work? Well, let's start with 1 and 30. Now they're not going to work. They're going to make 31 or 29. Let's go to 2 times 15. Well, they'll make 17, but if we do a subtraction in there, which we do need because the value is negative, we can get to 13. We want a positive 13, so that means 15 is going to be positive and 2 is going to be negative. They're going to multiply to make negative 30, and they're going to add to make positive 13. Great, we're doing awesome. So that means that these two factors then are going to, this is going to be split up into them. So let's go ahead and do that next. So we're going to write 3x squared plus 15x, right? There's the first factor, splitting that up. And the next factor we're going to split that up is minus 2x. Minus 10 is equal to 0. With that being done, we can start our grouping. So we're going to go ahead and group those two together. And we're going to group this negative, but we got to be careful here. So when we take that negative, don't forget to add a plus in the middle there. So now we're set for grouping. So let's go ahead and continue with that. We're going to look for a GCF now between each of our groups, but separate. Just these two terms here, and then we'll do it again over here. So 3x squared and 15x looks like there's a 3 divisible in both, so we write it out front. It also looks like we can subtract an x out. Remember, when we divide x's, we're actually subtracting exponents, so we'll take an x, which leaves this one to become x. And if we take a 3 from 15, that's going to leave us a 5, and the x is subtracted out. So x plus 5 is what should be there. And remember, we should see this over here when we take our GCF. Right now we don't, but we can kind of see it there. Remember also that if the first term of your group is negative, you must take a negative GCF. So we're going to take a negative 2 because 2 is divisible in both of those. And there's not an x, so we'll just be able to take a 2. Which leaves us with positive x plus 5. Remember, we took a negative, so our signs should switch. Equal to 0. We should see, and we do, this term is the new GCF between our two new terms. Right? There's our one term, there's our second term, that's the common term. So we're going to GCF that out now, which is going to be x plus 5. We put our GCF out front to be multiplied back in, and then we write our remainder because these are now gone. So it's going to be 3x and then a minus 2. Now we're in factored form. Now time for the zero product property, which means that we take our two linear factors, we set them equal to 0, and we solve. So 3x, that's not a very good x, let's change that. X minus 2 is equal to 0. This means x is equal to negative 5. Let's go ahead and move this 2 over by adding its inverse. So we get 3x is equal to positive 2. And then we're going to divide by 3 on both sides, or x equals 2/3. Let's go ahead and do that last step, changing them into intercepts so that we know that these are points. And there's our points. All right. I'm actually going to end there because the rest of this factoring stuff you should be familiar with. If not, go back and find my factoring by grouping video and rewatch that. I'll make that available for you. But let's just review then everything that we've kind of done. You'll notice that there is a little PST here, but that's also another video you can find. So we were able to factor by both a does not equal 1 and a equals 1. Additionally, we talked about the only new piece to this whole section, which is zero product property, which says that you can take your linear binomials, set them equal to 0, and solve to find the intercepts. All right, thanks for watching. We'll see you next time.